Welcome back to our digital electronics series. In today's episode, we're exploring the fundamental building blocks of memory and sequential circuits, flip-flops. Flip-flops are the basic storage elements in digital electronics, crucial for designing everything from simple registers to complex memory systems. Let's dive into how flip-flops work and their role in digital circuits. In digital electronics, a flip-flop is a bistable circuit that has two stable states, represented by a binary 0 and 1. It can store a single bit of data and is used in a variety of applications, including memory storage, data transfer, and control systems. The most basic type of flip-flop is the SR flip-flop, which stands for set-reset. It has two inputs, set and reset, and two outputs, Q and Q. The outputs are complementary, meaning when Q is high, 1, Q is low, 0, and vice versa. There are several types of flip-flops, each with its unique characteristics and applications. The most common ones are the SR flip-flop, D, data or delay, flip-flop, JK flip-flop, and T, toggle, flip-flop. The SR flip-flop sets or resets the output based on the input states. The D flip-flop, also known as the data flip-flop, is designed to store a single bit of data. The JK flip-flop is a versatile type that eliminates the invalid state found in SR flip-flops, and the T flip-flop toggles its output on every clock cycle. Let's focus on how a D flip-flop works, as it's one of the most commonly used flip-flops in digital circuits. A D flip-flop has a single data input and a clock input. On the rising edge of the clock, the value at the data input is transferred to the output Q. If the clock signal is not active, the output remains unchanged. This characteristic makes D flip-flops ideal for use in shift registers, data storage, and synchronization applications where precise control over timing is required. Flip-flops are the backbone of sequential circuits and have numerous applications in digital electronics. They are used in counters, shift registers, data storage devices, and control circuits. For example, in a digital clock, flip-flops are used to count seconds, minutes, and hours, ensuring accurate timekeeping. In computers, flip-flops are used in memory cells to store bits of data. They are also key components in finite-state machines, which are used to design digital systems with multiple states and control logic. Now, let's briefly discuss how flip-flops are realized in digital circuits. Flip-flops can be built using basic logic gates like NAND and NOR gates. By understanding how these circuits are designed, you can create more complex memory elements and sequential circuits tailored to specific applications. And that's an introduction to flip-flops, the building blocks of memory and sequential circuits. From storing data to designing complex control systems, flip-flops are everywhere in digital electronics. Thanks for watching. If you found this video helpful, please give it a thumbs up, subscribe to our channel, and hit the bell icon to stay updated with our latest content.